So in traditional software development, business people and technical people were more separated than before. See, leaders focused heavily on requirements and strategy, where technical teams had their requirements and then just delivered. But with Gen AI, those lines are blurring really heavily. And so in this video, I'm going to walk you through the foundational architecture that essentially every AI business leader needs to know to ensure that their products are going successfully. And then obviously along the way, I'm going to highlight real world issues that I've essentially encountered throughout every single step of the process. And really focus more on enterprise level as in Fortune 500 level, but this can still be applied towards medium and small businesses as well. So the first component here is enhanced context. Now, as you know, LLMs are really limited to the amount of data that it's trained on. So when we think about enterprise systems, we need to really ensure that we are getting the most recent up-to-date information. And obviously in a company, this would be the company information that we need to pull. Now, the most well-known pattern for this is retrieval augmented generation, or RAG. There's 3 types of retrieval augmented generation. Now, you've probably heard of the document retrieval, the unstructured retrieval, which we'll get to in a little bit, but there's also other types like structured data retrieval and also agentic retrieval, which all fall under the RAG categories. Now, for unstructured data, you can't just pass in the full document, right? You're going to hit context limits there. So what is typically done is you split it up into little different chunks. So whenever the query comes in, these chunks are automatically brought up with the query sent to the LLM. Now, not all your sources are going to be unstructured documents, right? There's obviously going to be structured data involved as well. And this is where you think of text-to-SQL pipelines, where your question gets converted into a SQL query into your database. And then that data is obviously then sent to the LLM. Now, for agentic RAG, this is hitting API calls. Maybe this is a web search, things of this nature, where you're going to dynamically fetch things based off of the query. Now, when you're running these sort of traditional AI projects, like what are some of the problems that, customers are going to bring up? So a customer might ask, hey, I'm asking a question, but I'm just getting the wrong answers every single time. It might be that the retriever is pulling the incorrect passages, and then you have to adjust the thresholds. You'll talk with the team to kind of adjust that issue. It could be that the users are just asking vague questions, so there was no way that the AI could pull it to begin with. And so this goes more into the user training aspect. Or, and I've seen this personally, unfortunately, clients are asking questions on data that isn't even in the application to begin with. And then there's obviously a data loading exercise and all those other pieces too. But the point of this section is really understanding how the context construction works, so that then you can obviously create new capabilities, but then also triage issues with your customers very, very quickly and address the technical teams to fix it faster. Now, the next component is guardrails, and this really helps you reduce risks inside of your application. And they're honestly added everywhere where there could be a potential failure, but there's really 2 main types that you should be looking at: input guardrails and output guardrails. We'll start with input guardrails. This prevents the system from actually getting sensitive information to begin with and then passing it into the LLM. But let's just say somebody is typing in their social security number and then sending it to the AI. We obviously don't want that data to leave our system, and definitely not send it to OpenAI. So this is where we need detection scans to make sure that this is not going to go through. So personal identifiers, if it's an image model, maybe human faces. There could be keywords, so IP specific towards your company IP that you don't want over to OpenAI. But once they're detected, you essentially have 2 different ways. You can either block the query completely or mask out the information, which you'll see here. Now, the second is output guardrails. Again, same as before, but this is also where we catch formatting issues and things like that. Now, there was a really high profile example at Samsung a couple of years back where employees accidentally pasted extremely confidential information on a Samsung project that they were developing internally. Now, obviously this was a large data risk, and these things we should be catching ahead of time. Now, there's also the concept of self-hosting as well, where you can self-host an LLM, so the data would never actually leave your environment to begin with. And so here you may not need as many guardrails in place, but that's kind of a separate piece, typically for government clients or financial services. But this does take me to my next section, which is model router and also model gateway. See, a gateway is kind of the interface between the application and the LLMs themselves. So not only does it help you when you are developing, so instead of having to change every single application, you just change the gateway, but there are practical pieces such as access control, cost management as well. There's a lot of different pieces that the model gateway also will help out with. Now, routing goes hand in hand as it will kind of predict the intent of the question, and then it can send it to the right solution or the right model. I see this a lot in customer support chatbots, for instance, where if a person is asking to reset a password, then they go to a different page. If it's a billing mistake, it might go directly to a human operator. And then if it's a troubleshooting kind of issue, it might go to a, fine-tuned LLM for internal purposes that's shared over to them. Now, why does this matter in general? right? See, one is that you can have specialized models for individual tasks, and this is really important for multi-agent architectures as well, where each agent can have its own specialized LLM. But second, and I would say this is actually more important, is cost control. See, not every query needs to go through, GPT-5, which are extremely expensive. And so if you can detect ahead of time, then you can use the LLM to save the inference cost. And this is why it's essential for Fortune 500 companies, specifically when we think about scaling. Now, the last one I want to get into is complex logic, but before that, let's just kind of walk through how the application is working right now. See, let's just take a common enterprise process like vendor onboarding, for instance. And so a user might ask here, can I onboard Brightleaf Analytics today? Their TIN is 123456789. What docs do I need and who approves it? Now, how can our system handle this? First, you'll have input guardrails, so you'll detect the sensitive data. TIN, we should be redacting this, so the input guardrails will stop that. Now we'll do the retrieval process, pull things like vendor onboarding documentation, compliance checklists. We'll pass the chunks in, and then we'll also pass the user clean query in. Then the model router says, look, GPT-4o is good for this. Then from there, we create our answer. We go through the output guardrails. We say there's no PII usage, and then we send it back to the user. Now let's move on to some advanced logic here. The previous example, the answer just went directly back to the user. But what if we need to do more than that? What if we need to have write actions? What if we need to route it back in on itself? What if there's a workflow that we need to accomplish? And this is where we sort of go beyond the simple questions and really start chaining things together. So the important things you need to think about are workflows, which is predefined rules. You'll kind of have a rule-driven sequence of what needs to get done. There are agents. This is where you have reasoning loops. And then the system decides when it should be taking action and when it shouldn't. And then you have multi-agent systems, where you have multiple pieces of these agents that are interacting with each other. And this is what I mean by complex logic, where we extend past just the simple input output to the user. Now, this is the foundations for Gen AI. In my next video, I'm going to go into agents, multi-agent architectures, and things like that. But this video is important for understanding the foundations of those other pieces. So anyways, thank you so much, and I'll see you in the next one.